So as I mentioned, there are two products, SBOM 360 and SBOM 360 Hub. So I'll quickly go through an SBOM 360 Hub kind of a use case where the whole journey starts from a procurement manager requesting for an SBOM, right? So when a procurement manager requests for an SBOM, the procurement manager can request from from a single producer, like basically software vendor of yours, and then you can request for either one product's SBOM or you can request for all the SBOMs, right? So this is just a simple request. Obviously, not many people know about Lineage, and even less people have deployed Lineage, right? So what this does is that actually it sends out an email from the procurement manager to the customer, and then the customer gets a email notification that there is a request to upload an SBOM, right? So the customer then clicks on that particular link, comes in, they create their own tenant, which is their own account. This is all free because the procurement manager has paid for it. So the customer then decides, okay, I'm going to share my SBOMs with this particular customer who is asking, and they come in, they get to a similar type of a UI where they can now go and quickly upload their SBOMs. So you can either upload one or thousands of SBOMs. It really doesn't matter how many you want to upload. You can directly upload these SBOMs. You may have generated these SBOMs from other software composition analysis tools like Black Duck or SNCS of the world. We are okay to ingest any of those SBOMs as long as they are in SpeedX or CycloneDX format. So once you upload this, what we quickly do is that we actually go and uh, do a quick assessment. Like number one, we verify whether the SBOM is actually compliant as far as the SpeedX format is concerned, the SpeedX standard. So in this particular case, this one was one. It's a publicly available Black Duck generated SBOM for the light point component in Tradix. And what we found was, okay, this is not even compliant, right? So as far as the SpeedX format is concerned. So this is one way of evaluating for as far as the procurement manager is concerned. The second way is that, okay, there is, you could also, if the SpeedX is valid or the CycloneDX format is valid, we then look at all the exceptions that are there, right? Okay, they may have included, in this particular case, they have included several component but details, but the details are not complete. So there is no way to verify whether this particular SBOM is actually for this UCE product that is included. So that attestation is not possible. So because of that, what ends up happening is the procurement, on the procurement side, you're still open for a SolarWinds kind of an attack. So let's say the customer provides a good valid SBOM, like something like this, where the compliance checks are all good and everything is passing. So then what you can do is that you can go and assess that particular SBOM. When you assess an SBOM, we do a full deep dive of this particular software. We open up that particular SBOM, identify every one of the components that is there, and then what we generate is a whole risk graph for you for this particular software, where we tell what is the tamperability risk, which means that you have acquired this particular software and the chances of a tamper getting through either in this one or in an update of this particular product is very high, because the score of the component attestations is just at an LCAL level 1. I will get into the details of how we achieve LCAL 0 or LCAL level 4. Okay. So this is one aspect. And then the second aspect is we calculate the inherent average mean inherent risk score of every one of these components. And for the inherent risk score, we consider provenance, where did the component actually originate from, vulnerabilities, the age of the component, security posture related violations, code quality related violations, and licenses. All of those are considered, and then this gives you an overall risk of this particular component. So you may be shipping a component that is absolutely good and there is no tampers. So it may be an LCAL 4, but you may be shipping an exploitable vulnerability within the component. So that means it is going to score somewhere, the star is going to look somewhere over here, right? Which is still an indicator that there is something wrong and this particular product needs to be fixed, or at least a VEX document has to be requested where the vendor then tells that, okay, what is it that the how to work around that particular issue. All right. So so yeah, so this is one. And then the other thing that you can do with this further is that you can also start writing your own policies, as I mentioned. So you can have your legal team can come in and write the policies, your security team can come and write the policies. Any number of policies can be written, they can all be linked to a single program, and that program can then be attached to all the SBOMs, right? So as these SBOMs are getting either procured or they are getting built, the violations are automatically detected and they are alerted for you as the user. So here is a simple way of how to create policies. Like in this case, I'm creating a policy where I'm talking about highlighting a finding if a particular software is shipping with vulnerabilities with a CVSS rating of 9 to 10, which is marked as critical, right? So from a findings severity point of view, it is marked as critical. You can also include other rules around licenses. Like, for example, you're including in your commercial product, you're including certain licenses, which are like copyleft type of licenses, which may be dangerous because that kind of mandates that you open source those particular components as well. So you can do these kind of checks very early on rather than actually ending up using bad libraries or deploying that particular product. Right? Then the third one is obviously provenance. You can check for where the component actually originates from, as well as code quality, like, okay, where binary artifacts or have you forgotten any secrets or embedded secrets in your code? This is code quality related checks. Or security posture, where we do checks for every single component, like whether branch protection is enabled for your transitive dependencies. If it is not enabled, then you're open for attack, right? So security posture, code quality, as well as finally the age or the maintainability of the component is also considered. And you can just quickly write your own set of policies, and then you can attach it to your SBOMs, and it can start including all the violations of your SBOM. Okay. So I think I didn't cover this portion of it. So what do we mean by attestation or a lineage component attestation level? So when we decompose, like in this particular case, right? So this is a container image. The container image has got several components, whether you have built those components or you have borrowed that components, it really doesn't matter. We open up the container, we look at every one of the component, where it is sourced from, and then we generate a whole attestation map, right? So when a component is mapped and scored at a level 0, what it means is that essentially the only information that is available for us is the component information, like the component information and then the version number and who was the supplier. We have no idea where did this particular open source component actually originate from. So that's why we marked it as third party, because wherever the package URL where this particular component is supposed to have originated from is missing. It is not available in the Maven repo. So that means that this particular component can actually not be verified at all unless you get a special access to this source repo from this particular company, right? So this is one. This is a level 0. Level 2, there are some components in this particular case. What you will see in the level 2 is you will see a component where the component details are provided, the package URL is found, as well as the checksums are matching, right? What you're shipping versus what has been published by Antler, both of them are matching for 2.7.7. However, the source repo for this has not been tagged, so we are not able to now do a tamper detection check between the what is shipped and what is being sourced. So that is why this particular component scores an attestation level of 2. And then the typically rest of the components, if they are scoring level 3 or 4, what you will end up seeing is that, okay, we can now look at the entire lineage of this particular component, right? Which commit ID, which is the source repo from where this particular component was built, and it was published in this particular package URL location. The checksums were verified, as well as the component details have been specified properly. So this is a good component, and this means that, okay, there is very little chance of a tamper risk for this particular component. So this provides the attestation evidence for the government organization when they want to, or your customers when they want to audit your internal processes. You can provide these things, and then they know, okay, they know about the internal details, how your product is actually being built, and these maps very well to the executive order requirements. Okay. All right, so that is the attestation details, and then provenance is basically decomposing every one of the software, and it tells you, okay, who actually authored, where did your borrowed code actually come from, right? So you can actually find out, okay, how many Russian authors were there, what are the number of commits that they have done. For example, okay, you click on this particular user, okay, this Andy Wilkinson from Pivotal has contributed very heavily to this Spring framework. Okay, and these are all the commits where this person has committed from. What is the risk of each one of these commits have been evaluated, and then that detail is provided to you, right? So this information, the reason why this information is valid is when US Air Force came and asked us that this particular point, this was very critical and important for them. Okay.
So, and then we have about 5 more minutes before we need to try to finish it off and leave some room for questions. So,
I'll be done. I just need 2 more minutes. I'm almost
okay, great.
okay. So then there is vulnerabilities. There is, I mean, this is a very simple standard process. Okay, find out all the vulnerabilities in your component and then make a list of it and let the user know, okay, how many vulnerabilities are there. Similarly, security posture, which ones are critical to be addressed, or code quality, or suppliers and license, right? So I'm just quickly going through because, okay, great, I discussed all these things and I have thrown a bunch of more problems at the users. So what? How do you help me in remediating these things, right? So you have a limited software group or a software team, and then you want to remediate all these vulnerabilities. So what we have just released, and this is what we just announced with Black Hat, is, okay, we have released a small AI module, and we call the features of this particular AI module as bomb bots. What There are multiple types of bomb bots. In this case, there is a vulnerability bomb bot, right? So you can ask this particular bomb bot anything, like things like, okay, it can explain to you what are the vulnerabilities that are there in your software, uh, where are the fixes, as well as just 1 minute. So it can respond to you these details. You can get all the additional details right here within the chatbot. You don't have to look at the UI in any way. You can also ask it a simple question like, okay, uh, recommend vulnerability fixes. So when you do this, so essentially what it is actually doing is that it evaluates every one of the dependencies or the components, creates a tree for you. And internally, what it is doing is that it analyzes the components that have the vulnerabilities. And it doesn't just recommend you go and patch those to the latest version. Rather, it looks at the entire tree structure, and it recommends that you go and patch only certain components, and it tells you which version you have to upgrade to, so that your overall compatibility is maintained. So from an engineering cost efficiency point of view, this is very good, because now your developers are not scratching their head and trying to figure out, oh, I upgraded to the latest version, but now my software doesn't work, right? So rather they just go upgrade to the version that is recommended by the bombot, and then they know that, okay, these vulnerabilities got fixed. For example, in this particular case, the number of vulnerabilities dropped heavily, as well as the compatibility of the software was also maintained just by applying these 6 targeted patches. Okay, so that is what a BOM does. And then it can take this, because we know the lineage of every single component who brought it in, we can then take this data and we can just directly add it in as your Jira tickets for your customers. Okay. Cool. That
Okay,
is
is
it.
that it?
Yeah, that is it. So I'm going to pause here. Any questions, please continue.
So we'll open up the questions, but I have to ask a couple first to kind of just set the tone.
Yeah.
So as
Yeah.
so it appears to me this is an enterprise level software. Uh, is that correct? Have you
Yeah,
had?
it is an enterprise, software, but yeah, but individual developers can also make use of it. Like we have a free version that is available for all the open source contributors. They can come in, they can log in with their GitLab, whatever account, and then they can manage their entire software for free completely.
Wow. I'm going to definitely try it out. And because I mean, we have a typical big Java layer, which I believe we have Sonar and Nexus. It's all, every time we run a build, we go to Nexus. There's some services involved, but the NPM side of things, the web side, uh, you know what I mean? I'm not sure what's
Yeah, I
going on
know. I mean,
with
like
node
things are changing
modules.
very exactly. So the things are changing so heavily. It's difficult to keep track of what is in your software, and that's one of the reasons why we went and built this. And what we found was that none of these SCA tools are actually secure, right? It's very easy to work on these tools. Yeah.
Right. How what what type of libraries are you I mean, don't you have a lot of legacy kind of competition for security testing and analysis, like in the C++ and Java world, and also in the machine image world, and then probably like the node world is like a new growth area for where you have to look for stuff and to monitor, like, and also business wise, like where's your competitors? Aren't they already embedded in the old libraries development world?
Yeah, yeah. So I mean, yeah. So let's take Black Duck as an example, right? So Black Duck primarily, if you remember, like majority of the times for a merger and acquisition was when everybody desperately creates a whole bill of materials. They try to tell, okay, this is all my third party borrowed code, or this is my open source code, this is my private code. They do or they may do a protect scan for your IP related verifications and stuff like that, right? So yeah, so old world code, those tools are still relevant and they can be looked at as a competition, but we go far beyond what those tools actually do. So if you think about it, this is what a next generation SCA kind of a tool, or a tool that helps you manage your software supply chain looks like, right? So it's
Understood.
an end-to-end solution where both from a software procurement as well as from a software producer, you have all the tools at your fingertips, right? And we support a lot more languages at this point.
Thank you.
Hi, Anand. I had a question for you.
Hey,
Um,
yeah.
Where do you get the list of vulnerabilities? And the reason I'm asking is the list of vulnerabilities presumably changes for
Yeah,
existing software versions. So I might do
absolutely.
this analysis and conclude, oh, okay, I'm at this level, but actually vulnerabilities are found after that that lower the score of my existing software. And how would I know about that without coming back in here and doing more analysis?
Absolutely. Good, great question. Okay, so one is so we look for vulnerabilities from multiple sources. Okay, we are we are not actually doing weakness analysis and doing vulnerability finding. Okay, let me be very clear about it. What we do is that, okay, we look at every component, then we there based on the CPE requirement standards, we generate a bunch of CPEs, and then we look for that particular CPEs in multiple vulnerability data sources. Okay, and we generate the vulnerability list from there, right? So that is number one. But your question is absolutely valid in the sense that even after a software is built and shipped, new vulnerabilities keep getting discovered. And that is the reason why what we have is an automatic way of notifying both the software producer as well as the software consumer that, hey, you have shipped a piece of software to the customer and this was 6 months old, and today there are 5 more vulnerabilities that are available or that have been discovered. So you need to then provide a vulnerability exchange or a response to your customer. So we enable the software producer to actually go and keep their software kind of patched or up to date by being very proactive. And they use vulnerability exchange to actually say whether they are impacted by a vulnerability or not. And if they are, what is the workaround that the vendor should be doing? And that happens through the SBOM 360 hub. So now that is just for vulnerability, right? So similarly, you may have written a policy that, hey, I want to keep an eye on a specific author who is contributing source, right? So if you see a bunch of activities from that particular author, that would also create a dynamic findings for you. Okay, so this is not a vulnerability based detection, but this is more of a findings or your policy based violations. So both of them are considered violations and they are notified. So it is just that you as a software producer react for vulnerabilities, you react and you let your customers know, whereas for the other findings, you may decide to either issue a patch or an upgrade, or you may even decide to actually flip and get rid of that particular component in your next release, right? I think there's a question on the chat session. Sorry.
Anand, I have a question.
Yeah, go ahead, please.
See, the product looks very good. One question I had is on the you could classify the library as open source.
Yeah.
Do you also classify under the open source what kind of license it is applicable? What is the license that is
Absolutely.
that particular library is of?
Yes. So in the suppliers and license tab is where you actually see the true set of suppliers. So typically, if you go and ask your procurement manager, they may not give you all the details, right? But this is the true set of licenses, suppliers, and these are the total licenses, that type of licenses that have been included, right? So this is your entire license from a groupings or category point of view, right?
Okay, excellent.
So this open source seems like one of the issues is as you go to use it, you would like to know provenance of it at the time you select it. Now, this doesn't really help that. Is there a way this could help that?
Sorry, say that again.
So when you go to select an open source module that you're going to incorporate, okay, you would like to know the provenance of that module before you actually do any work with it.
Oh, yeah, absolutely. So for example, you can, let's say your developer wants to go and use a new open source component, right? So what the developer can do is that either they can go to the SBOM 360 hub or SBOM 360, and they can go to the open source and they can just search for the component that they are interested in, right? When they search for that particular component that they are interested in, they can immediately, like for example, okay, let's say I just pick some random thing over here. So when you search for the component that let's say, let's wait for the response. Sorry, it's taking some time. But when you get the list of the components, you can pick your library of your choice and you can do the same evaluation that you're actually seeing over here, right? So let's say, okay, faster XML, you can then go and look at, okay, what is the vulnerability, or what is the rating, risk profile rating here? Even though pretty much majority of the components are at an LCAL level 3, what you're seeing is the vulnerability is probably bringing down this particular component because it includes 50 critical vulnerabilities and some of them are exploitable. Sorry,
Right.
Yeah, go ahead.
So my real question is there a way a developer could do this on a one-off basis as opposed to just purchasing the system for all of their software? They're just getting started or whatever.
Yeah, they can do it on a one-off basis, but then if you look at the entire enterprise org now, what you typically have is you have a DevOps or a DevSecOps team. And also there is an open source program office, right? There is a third-party procurement and there is an open source program office. So an open source program office or your DevSecOps team may actually want know they may need to know all the list of libraries that you're including in your software, whether it is open source or third party, so that they can do these security evaluations prior, and they can give an approval or they can block a particular build from or a particular component from getting used.
And,
So
what would something like that cost? I mean, just range.
sorry?
And what would the cost for a one-off kind of use like that be?
Oh, so one-off is free, right? As I mentioned, like, okay, you just come in, log in with your GitHub account, and then you can start searching. If the component is not there, then what you can do is that if the component is not there, you can go to the integrations, go to the GitHub, and then just say that, hey, I just want to start scanning that particular component. You just add that component and you scan it, and we will generate a full SBOM for it. And we will also automatically publish it for you. And then you can see what are the violations of that particular component.
Okay. Any other questions? Anyone? I have a lot of questions about the details, but it's probably all proprietary. Leo?
I have a question. Let's say I publish a component, and it's quite common that one of the things included in my component, one of the open source components, say that I incorporated, it has a known vulnerability in it. But many vulnerabilities only involve certain use cases or certain APIs of the incorporated component. How can I attest that I am not subject to that vulnerability? Like, it's true that that vulnerability exists, but it exists only in a certain API of the subcomponent, and I don't use that API, therefore I'm not subject to the vulnerability. I'd like to publish the fact that, yes, I know about that, and I've looked at it, and it's irrelevant.
Yeah, absolutely. So there are what you can do is that you can use our AI module or what is it, the BombBot, and then you can actually generate a fix recommendation for yourself for the vulnerabilities that are that are impacted for your call graph or for your specific code paths. But for the scenarios that you mentioned where you're shipping a component, but you're not using the APIs or the module. Let's take Log4j, right? The critical vulnerability was in JNDI manager, and and you're never using it. That if you can prove that, then you can pretty much say that this in the Vex document that I am not using this in my source base, and hence it is not impacting me. Now, how do you do that? Is that you can now go to our AI component, and then you can actually look at that particular vulnerability, and you can see whether that is part of your call graph. Now, this is something that we are actually automating this whole process. So at a later point, maybe I can come back and show it to you guys. Okay.
I kind of follow that you're saying your AI component can analyze the call
Yeah,
graph to do that. But let's say I've already done that work.
if you
And I would like to.
if you have done
I
that,
like.
yeah, if you have done that work, then you just call out a particular vulnerability, and you can ignore that, and then in the Vex documentation, when we generate with your SBOM, that is automatically marked as okay, not impacting for your software, and we provide the reason that you have provided. Right? There's a workflow for that.
Okay, yeah, that's what I was asking about.
Yeah. So, but however, remember one thing. At any given point of time, there may be an audit, and you may need to provide the evidence for it. So how do you provide the evidence for it? That's one of the reasons why we are building in a lot of these mechanisms within the tool itself. So now, next time around, you may actually, when you ignore something, you may upload a particular call graph or a call stack file as an evidence. We can store it for you. We can display it whenever there is an audit that is happening. But we can also do this automatically for you. But However, that one notion, let me be very clear, right? Call-based reasoning that I'm not impacted by this particular vulnerability because I may be shipping the library, but I'm never using that particular API, is extremely subjective to what kind of language a particular module is using and what is the system that you're deploying it in, right? If it is a C++, and if it is deployed on a Windows or something like that, you should not be doing that, because it's a much larger problem. Because now, okay, what is the system on which you're deploying your software and stuff like that? There are a lot more parameters involved over here, and it's easily breakable at that point. All right.
I just had a question here. So if all this, so essentially all this documentation, everything like that, if I'm an enterprise user or whatever, I get I'm just accessing this information that you're actually storing for me, right? I don't need an install on-prem somewhere to have this data set,
Yeah,
here, there, or everywhere, right? I don't need to worry about that, right?
exactly. So yeah, so we work in two modes: a pure cloud mode. Okay. So in a pure cloud mode, you don't have to deploy anything. You just have to finish your SCM or your container repository integrations, which is basically permissions, read-only permissions, and then we automatically can do rest all of the job completely without any deployment, right? This is one way. But there are some companies where source code repositories, they build Artifactories kind of out of bounds. Okay. So if that is the case, then you can take a small CLI component that we have written, and you can download the CLI component, and you can just install it within the same VPC as your source repo, and then provide that component, the command lines that have been provided. We will do all the dependency crawling over there, but we will do rest all of the analysis in the cloud. So, but rest assured that we don't send any sensitive data to our backend. We just send some simple metadata information at that point.
Okay, thanks.
Anand, one more question.
Yeah.
In terms of the entire stack of Lineage, is it to be consumed only as SaaS, or can it be hosted in-house? Because given that we work in a fintech industry,
So
we face a lot of challenges in terms of hosting something public.
yeah. So if you we can host it in your AWS account completely. So we can take our entire backend, everything, and we can we've done that for a sensitive, large 3-letter word organization, but we can do it for you.
Okay,